In this tutorial, we are going to examine the block that we just created, the multipath hierarchical block. We are going to examine its impulse response and frequency response and check the characteristics of the fading channel based on changing the delay and the delay gain. In order to do this, and by the way, this is to illustrate the use of hierarchical blocks and reuse. So let's go ahead and create a new blank topology. And the first thing we're going to do is we're looking for the impulse response of the multipath channel. So let's go ahead and create an impulse. There's a block called impulse. You can actually type it in or go through the list and of course select it under impulse. We'll go ahead and hit OK. Let's move this out of the way and park the impulse right at the beginning. The next block that we need is the hierarchical block that we just created. In order to get the hierarchical blocks, we have to click on this icon for hierarchical blocks and we'll select the multipath. Hit OK. Of course we can move this out of the way and let's place it right over here. Now the next block we want to place is the spectrum block. Now we could have done that from the block selection and done it all at once, but this is to illustrate the procedure in general. We're going to go ahead and connect the output. Very simple. The impulse block generates 128 samples, and we'll just leave it at that, but we can increase this to get better precision. But we'll leave it at 128 samples. Now, the multipath block itself, let's take a look at its parameters. These are the parameters we created before. We have a bulk delay of 5 samples, a multipath gain of 0.4, and of course a multipath delay of 6. So it will be interesting to actually look at the impulse response and also the frequency response. So let's go ahead and run the simulation. We get two plots. One is the frequency response and the other is of course the impulse response. You'll notice that we have the bulk delay and we also have the delayed multipath with a gain of course 0.4, and you'll notice that in the frequency domain we have the basic peaks and valleys of a multipath channel with a single ray of multipath, and the distance between these minimums or valleys here, which are actually very bad for communication because these actually wipe out the signals. If for example we have energy and these are a carrier within these regions, they would actually be fully attenuated. And the deteriorating channel is determined mainly by the ratio of the peak to the valley, but also the number of valleys within a certain bandwidth. So let's go ahead and take a look at this. Let's keep this spectrum plot around and go into and change the delay. We'll take the delay and make it actually 20 samples and do a run, and you'll notice that the impulse response, obviously the delay has shifted out, but in the frequency domain, the frequency response, we have many more of these deep valleys within a fixed bandwidth, and of course this is a much worse channel than this channel, and we actually see that in the eye diagram when we looked at the end-to-end simulation for the digital link. Let's go and keep this plot around, and the next thing we're going to do is change the parameters. We're going to reduce the amount of multipath gain and see what effect that has on the simulation. So if you notice that the impulse response now, the delay is much smaller. You still get the same number of deep fades within a fixed bandwidth as before, but of course the ratio between the peak to the minimum changes quite a bit and decreases. Let's also look at the case where we go and revert back to the case where we only have very little multipath delay. We'll take a look at that, where we had only one sample, and of course it looks very much like an impulse, and of course the distortion is absent or very little, as we noticed in the eye diagrams, was quite open in this case. So basically we're reusing the multipath block, the hierarchical block, as a typical block, and we're looking at the impulse response as very easy to actually analyze both the impulse response and frequency response for the multipath. There's nice mathematical formulas for predicting the actual ratio between the peaks to the valleys, and also the number of the periodicity that you see in the frequency response in terms of fading and so forth. We'll get to those later. Actually, the tutorial will include some additional material that covers that topic, and you can actually verify the theoretical predictions with the actual simulated impulse response and frequency response.